Hey guys, welcome to Unit 3, Section 4. I'm reusing this slide, it probably looks familiar. But today we're actually going to practice using triangle congruence proofs. So we do need the shortcuts when we're doing these proofs just to help us out, otherwise it would take a very long time to prove everything. So remember, side, 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 angle, angle, side, angle, and hypotenuse leg are the 5 ones that we're going to use. We are not going to use SSA or AAA. Those are not shortcuts. Okay, so let's look at our diagram here. Now, this is what is called a 2-column proof. We have our statements, and then we have our reason. A statement is going to look something like this right here. This is where you are comparing things, usually in an equation or some sort of congruence statement like what we have there. And the proof statement is always going to be the last part. So I actually know where this part here is going to go. It's going to go right here. I can just copy this. If that's the first thing you want to do, that is totally fine. But it's always going to be the last part of our proof. It's going to be on the last line. Okay, so we are trying to prove that these two triangles are congruent. Triangle BIE is congruent with triangle KEI. Now, the given, when you're taking a test or a quiz or something, that'll always be given for you. Usually we don't have to identify that, but I want you to practice looking at the diagram and deciding what information do you already know. And if you look at it, notice we have the 2 tick marks on the top and the bottom. So that first tick mark is for BI. We know that line segment BI is congruent to line segment EK. And that's because of the given. The other thing that we notice, if you recall, that these arrows mean that the 2 lines are parallel. So we can also say that line BI is parallel, so we use that little symbol there, or you can write it in words, with EK. All right, so we have 2 lines that are parallel, and we also have those same 2 lines are congruent to each other. Now we need to find some more information, because we need to get one of these shortcuts up here. So right now we have a side, so we're probably going to use one of these. Since it's not a right triangle, we're not going to use HL. Okay, so then the next part about a proof, because what a proof is it's justifying our reasoning as we're going through our statements. So the first statement is always the given information. So we know that BI is congruent with EK, and then we also know that BI is parallel with EK. Usually it's just one piece of information that we're given, and that goes on the first line. It's fine though, we're just going to use it for both. And then the reason, well, it's given to us. There is no real reason behind it. Next, we want to identify something else from the diagram using the given information. So one thing that you might notice, this is my favorite thing to talk about, notice that the 2 triangles share a side. So whenever they share a side, we're always going to do this trick. It's going to be that side, which is EI, is congruent with itself. Since it's a part of both triangles, we have to recognize that they share it, and therefore it's congruent to itself, and that comes from the reflexive property. And remember, think of reflection when we're talking about the reflexive property. If you look into a mirror, you see yourself. Okay, so now we have 2 sides. We have side BI and EI for the top triangle, and then side KE and EI for the bottom triangle. So think about, could we find the third side? Is there any information that could justify that third side for both are congruent? Well, not from this diagram. So if the 3 sides trick won't work, then we have to look for an angle. Now remember that these 2 here, they told us that they're parallel. When we've talked about parallel lines this year, we were talking about transversals. So if you recall, if I were to extend these lines like this, and then if you look at this line that divides them, or goes through both of them, this actually could be considered a transversal. And when we have parallel lines and a transversal, we know a lot of information about specific angles. And if you look at this angle here with this angle here, those would be alternate interior angles if we think back to our angle pair relationships. And since lines are parallel, we know that alternate interior angles are congruent. So we can say that angle BIE, which is this one right here, is congruent to angle KEI, which is this angle right here. Okay, so by using those, we have proven that we have a side, an angle, and a side. But how do we prove those again? That is the alternate interior angles. We need to make sure, how did we prove that they were congruent? And it's technically a theorem, but if you just write alternate interior angles, you get the idea for this one. Lastly, how did we prove that the triangles are congruent? We got to where we need to. We have a side, we have an angle, and then we have a side for each triangle. So we use the shortcut of side, angle, side to prove they are congruent. All right, that probably feels really weird. The first time that we look at proofs, it's difficult. I completely understand. So let's go ahead and try another one here. All right, so this time we are given the information. BD bisects ABC, BD bisects ADC. And remember that the last statement is always our prove. So this is triangle ABD is congruent with triangle CBD. We don't know what the reason is that they're congruent. That's what we got to work on. So let's start with our given information. So BD, I'm just going to put bisects angle ABC and ADC, just to save us some time. Now, recall that the definition of bisect is to cut things in half, and this is because of a given. We didn't have to work for that information, they told us. So what does it mean to bisect? Well, if you recall, it means to cut an angle into two congruent pieces, or two halves. So if we know that it bisects ABC, which is this angle here, I know that this angle, ABD, is now congruent with the side angle next to it, CBD. So we can say angle ABD is congruent with angle CBD. And the reason is because they were bisected. So this is a definition. Bisecting is not a theorem or anything, so we put definition of bisect. Okay. Similarly, we also know that ADC is, which is this one right here. So that means that angle ADB and CDB, this angle right here, and this angle right here, since those are bisected, they're also going to be congruent to each other. So I'm going to say angle ADB is congruent with angle CDB. Again, it's because of the definition of, and technically this is an angle bisector, but I'm not going to worry too much about that. This is the first time you're seeing proofs. So that's definition of bisect, to cut in half. All right, now we know that two pairs of angles are congruent, so we need to find a side. We can't prove it with three angles. We need to prove that there's a side that they share or have that is congruent. And if you notice, again, they share this middle side right here, so we get to use that lovely reflexive property. So BD is congruent to BD, and that is by the reflexive property. You just have to be able to recognize that they share the side in order to use this one. Okay, so now if we look at this, recall our shortcuts, we have two angles and a side, and that side is in between the two angles. So this is angle, side, angle. And there we go. We've proven that the two triangles are congruent. for both examples. So we're definitely gonna do more practice with these in class, but